Hello, welcome to another stream. How about that? How about that? Welcome. Hello, Sasalala, Yatanasa, Shigiman, John, Out9, Shigiman, Yatanasa, that's it. I don't see anyone else. There's only you guys. Welcome to another stream. Asintos, welcome. And Course 94. Hello. So today is Saturday, and that means today, according to the schedule, we're supposed to be doing game development. Hello, Go on the third. But yesterday we studied a pretty interesting topic of exploring different cellular automata. Surimun, hello, welcome. And we didn't really finish it, right? I didn't look into more interesting cellular automata. So today I decided that I'm gonna continue doing it, right? So you can check out the source code we've been developing here yesterday. So yeah, and today we're gonna just continue developing all of that shit. That's right, today we're gonna continue developing it. Yesterday we managed to implement only two cellular automata. So first rule 110 and the second one game of life, like, you know, the two famous ones, which are not really that interesting because they're sort of cliche of cellular automata. So it will be interesting to implement something actually different, but we can take a look at them. So it's something like Cellular Automata. So do I have any changes in here? I don't have any changes. Fetch the latest stuff. I don't know if I actually did anything off screen. I think I didn't do anything off screen. Alright, so rule 110, it actually looks like this. It's pretty straightforward. I'm pretty sure a lot of people actually saw it. Maybe it would be even better to make it slightly slower, if you know what I mean, because it's passing by too fast. Right, so let's actually recompile everything, and if I run it like this. So it's a one-dimensional cellular automata, right? One-dimensional one. So essentially in this particular... I just realized that I wanted to stop cellular automata by pressing space. Maybe this is one of the things that we'll have to implement. Yeah. So let me go and do that. Something like pause on space, and it will be kind of cool to have that in all the cellular automata. I don't know why I'm trying to say automatas, because it's like sort of natural for an English language, but this like automaton is probably a loan word, and that's why like a plural and singular are different, and this is something that you have to actually memorize and stuff like that. I don't know, it's one of those weird English words. So essentially, right, each row is a different state, and the next state is generated on the previous state. So the state is not two-dimensional one, the state is actually one-dimensional, right? And this is basically how it looks like, and it generates very interesting, like these triangular patterns all the time, and yeah, it's pretty cool. So the next one is game of life. Probably a lot of you familiar with the game of life, nothing special. We actually put a bunch of gliders in here. As far as I know, like we have a code to add more gliders. Let me see. Let's see. So there's a special function that lets you actually put more gliders, and I'm gonna put it like that. Ah, fuck! Sorry. There we go. So this is now. It's kind of strange. Like, why did it scale? Oh yeah, probably because of the rebuild and whatnot. But yeah, so this is what we managed to do yesterday, and this is something that we're probably going to continue developing today, but we're going to implement more interesting cellular automatas. It's not automata. Yeah. Look at those boys gliding, exactly. Okay, so before we start, maybe I want to actually do pause on state. So there's a lot of other aspects of control. For example, I don't want to delay you know, a particular timeout of calculation of the next step, because while it's in a delay, it does not handle the events, right? It doesn't handle the events. And for example, if your delay is half of a second, right, and if you try to rebuild this entire thing, you try to close the window, it will only close on the next iteration of event loop, which makes it feel kind of sluggish, right? So I don't think it's a good idea to just delay things like that generally. So it would be better to actually maintain a constant FPS, right? And basically have a variable, like a cooldown variable that basically subtracts delta time on each iteration of event loop and then triggers the calculation of the next state when the cooldown becomes 0, right? And that way we'll be able to handle events in between the generation, which will reduce the sluggishness. Use pthread. All right. So let's quickly do that, like a little bit of this work. On top of that, I think the delay between generations could be something that is shared between different examples, right? We have a lot of different constants that are shared between examples. For example, width and height, amount of rows and amount of columns, and so on and so forth. So this is basically the code that is shared between the examples. And that's pretty convenient. That's pretty convenient. So yeah, so since we're gonna have a screen, I also want to define something like screen FPS. It's gonna be 60. It's gonna be 60 FPS, and after that, it would make sense to introduce something like next gen cooldown, or maybe timeout. I don't know. Maybe period. So basically, the amount of seconds between the generations. Next generation. Probably timeout will be a little bit better. And since we're gonna be doing like a delta time computations, and I usually keep delta time in seconds, this thing is gonna be flowed, and let's say that the time between the generations is gonna be like half of a second. I think this is the easiest way to actually do all that. So, okay, so we have a screen FPS, and let's introduce something like delta time in milliseconds. Right, because we'll need it in for the delay in the future, but first it's easier to define it in seconds. So we're gonna take 1 second and divide it by screen FPS, and there we go, we get delta time in seconds. So the next thing is gonna be in milliseconds. I guess the easiest way to do that is just take time in seconds. Maybe yeah, time in seconds, and multiplied by 1000, right? And you will get a time in milliseconds. And after that, it probably makes sense to forfeit, right? To forfeit and turn it into an integer, right? Because this thing has to be an integer if we want to feed it into the timeout. There we go. So we have all of the necessary constants. All of the necessary constants. So rule 110. So here's going to be the delay. In milliseconds, let's actually put it here. Yeah, it's gonna be delay in milliseconds. And we need to introduce some sort of a timeout variable, right? So next gen timeout. I don't really know if I want to call it like that. I'm not really sure, but I have no idea if there's any better way to do that. Okay, so we're constantly rendering everything, and on each update, so update is gonna be happening like around here, so that means I want to put it like somewhere here. Usually when I develop multimedia applications and games, right, so I usually divide my frame into following sections, right? So at the beginning of the frame, I handle all of the inputs, right? Handle inputs, then I update the state, I don't know why it actually shifts it like that, probably because of A style, and then I render the state, right? So I usually have these 3 phases. And I wanna trigger the next state in update state, right? So in here, what we have to do is take the next gen timeout and subtract delta time in seconds, right? We're subtracting delta time in seconds. And if next gen timeout less or greater than 0, right? We have to compute the next generation and reset the next gen timeout to next gen timeout. There we go. How's nothing mod working out so far? As you can see, it's working. Alright, so yeah, this is basically how we're gonna combat the sluggishness. So now the next generation timeout is not gonna affect on like how quickly we handle the inputs, right? So now we should be able to actually close the window between the generations. Hello, Deep Singularity, welcome to the stream. Hello, hello. So it would be nice to have that in all of the examples, but I don't really know how to extract all of that. Maybe what I'll have to do is I'll have to basically abstract away this entire loop, right? And ask the user to provide the callbacks. You're making Game of Life? I already made a Game of Life. You can check out what we do here, because every streamer on Science and Technology section have a bot where you can issue a project or today command that will explain what we're doing right now, so you don't have to ask that. And usually there is a link to the source code of what we're doing, where there is an explanation and everything, you know. Anyways, so here's the thing. So maybe we need to create some sort of like an engine, right? Some sort of like an engine that handles all of that for us, but I'm not quite sure how we're going to do that. Something like handle events, but we also need to be able to provide the callbacks and whatnot, if you know what I mean. So then we begin the rendering, because I want to abstract away all of these SDL calls. Maybe I'm gonna do, oh shit, I have an idea. What if I do the array-lib approach? You remember array-lib approach? Where is my Chromium? So I forgot how we called that game with array-lib. I think it was just array-lib probe. Yeah, array-lib probe. So I think that's a pretty good idea. I think that's actually a pretty good idea. Essentially have all of these functions, or maybe even macros, right? Like begin drawing, end drawing, and this one is not particularly interesting, but you can have like these nested sections and whatnot. And maybe this is what we can do to actually speed up the development of different examples, so we don't have to implement like this events loop all the time, and so on and so forth. I think that's gonna be okay. What did I just do? I did something really strange, but yeah. So pause on space, and this could be also something that is handled automatically. So I'm just thinking, what's gonna be the best way to do that? What's gonna be the best way to do that? Because we want to have like maybe custom, some sort of a custom handlers and whatnot. Sure. Okay, let me try to extract all of that. So maybe we're gonna have first something like automata begin, right? Automata begin, which we can actually tuck onto this code under, right? We're just tucking it under, and there we go. Your neighbor's banging? Probably. So then we're gonna have automata end, right? Automata end. And what's interesting is that we need to be able to store a state somewhere, right? Because every time we pull the state, we need to update this quit. So one way to actually do that is to have some sort of like a global automata state, which is not a bad idea, generally. I think it's an okay idea. So now, let's actually introduce a structure automata. And let's actually do type def, like this, and in there we're gonna probably keep just a boolean quit, but maybe in the future we're gonna have more of different stuff in here. So Automata, and we can say global. Yeah, let's just call it global. Right, it's just gonna be global, and it's gonna be 0. All right. So now I don't have to provide that, and I can just do Automata begin. Is it C++? Yes, it's a C++. Automata end. It's a C++. My favorite language of all time, C++. I absolutely love it. I think it's the best. It's better than C for sure. It's a great improvement over C. Now, so what else do we have? Let's actually put a boolean automata time to quit, right? So which also takes a void, and then we're gonna return a global quit, right? So, and that means here, while not automata time to quit, we're gonna keep doing this entire stuff. So let's introduce another function, something like automata begin rendering, right? Begin rendering. But to begin rendering, okay, this is another interesting thing. What if I want to be able to? Yeah, I need a renderer, but I can keep the renderer in a global state. Okay, so this is actually a pretty cool idea. So I'm gonna do SDL renderer. And it's going to be just a pointer to the renderer, right? So, and we might as well actually keep the window here as well. Okay, so we're slowly developing like a framework that we can use across several examples. Is this 2D or 3D cellular automata? It's actually 2D one. We're implementing several of them. So far, we implemented one-dimensional or two-dimensional, specifically Rule 110 and Game of Life. Right, so this is what we developed so far. I plan to develop more, so basically I'm gonna go into the Wikipedia page and just grab some more interesting cellular automata. I'm gonna implement them. So, but before I'm gonna do that, I wanna clean up my code and sort of develop like a very small framework for developing cellular automata. So it's a little bit easier for us to work with. 1D, well, is that somehow funny? Like, I don't quite understand. So, yeah, this is how it looks like. It's a one-dimensional one. So each row is a state of cellular automaton, right? And basically when you scroll from top to bottom, this is like a progression of one-dimensional state. And the progression of one-dimensional state looks two-dimensional essentially, but yeah, it's a one-dimensional one. Is that a problem, or I don't quite understand? So if you have any questions, feel free to ask, because sure, this is how it looks like. It actually creates pretty cool patterns, like triangular ones. As far as I know, like Rule 110 has its own gliders. Like you can see, this pattern basically goes across, you know, from left to right and evolves eventually. And yeah, it's pretty cool. It just can move around. It's sort of like a equivalent of a glider, but in one dimension. Yeah. All right, so let's continue developing the framework. So we're gonna have a window here, and yeah, this is how we're gonna initialize everything. So instead of saving it here, I'm gonna actually save it directly into the global, right? Global, and this is where we keep all of that. Okay. Why slow? Make it go brrr. Because I just run the last compilable version, and my code right now is not compilable. That's why. Does it make sense? Because I'm in the middle of developing the framework for this kind of examples. Once I finish developing the framework and my code is compilable again, I will be able to modify the time variable, and it will go brr. Does it make sense? Can you suggest resource to learn C++? It's kind of difficult to suggest any particular resource. I guess Stack Overflow is the best resource you can go for. If you want to like systematically learn C++, maybe one of the Strauss Trop books. But I don't know if systematically learning. Oh yeah, we have a special command. I forgot that we have a special command. Sermon, thank you so much. Yes. Yeah, Churn or YouTube channel is also pretty good for C++, I guess. I personally didn't learn C++ systematically, right? So what I did essentially, I just Googled up things as I need them, right? As a matter of fact, I didn't learn anything systematically. I didn't even know how to learn things systematically. So asking me for a book or resource is just pointless. Like I don't know how to learn things like that. Sorry. Anyways, so Hamikovi, welcome to the stream. How are you doing? All right, so we have a renderer, and for example, I want to have functions like board, actually not board render, but a render rect. Do we have a render rect? I should have a render rect somewhere, right? And what it does, it actually, yeah, it fills the rect like that, but we need to create a wrapper around these functions. Yeah, we need to create a wrapper around these functions. Well, we probably will do that eventually. I finally got you laptop, it's okay, finally. Congratulations. All right. So begin rendering. When we begin rendering, I suppose it's gonna be just like this. And the thing it does, it should just clean up everything, right? So essentially, we just put this thing here. We just put this thing here and begin rendering, and then automata and rendering, right? Not void, forget fucking damn it. And rendering. I heard more than once that you have a slow computer. Have you thought about to upgrade it? I have a... Well, compared to the computer that NASA used to, you know, moonland, this is a supercomputer. I'm pretty sure you can moonland with this computer millions of times, and way more accurate than Apollo computer, so... I don't know. The only thing this computer cannot do is to render DOM using React, because apparently it's a more difficult task than landing on the moon. Which is kind of sad, but it is what it is. So, let me see. So then we do represent, but we have to use the renderer from the global, right? We have to use the renderer from the global. Why don't you use better theme in your editor with colors, etc.? First of all, what is a better theme? How do I know that it's better? And second of all, I do have colors. Yeah, so here's the one color, and here's another color. And here's third color, and here's the fourth color. So, I don't know what you guys are talking about. I don't know what you mean by better theme, and I do have colors. So, sorry, I don't understand what you're talking about. Now. Are you colorblind? You're talking to me? I'm not a colorblind, actually. So here's the begin rendering, and then we do end rendering. So, and also we need to do this delay. But I'm not quite sure how do we do this delay. It's something like end of the frame, right? It should be something like end of the frame, but I'm not sure. We need to introduce something like beginning of the frame and ending of the frame. But that one could be kind of difficult. So by the way, how ArrayLib does that? How ArrayLib synchronizes everything? ArrayLib might be actually synchronizing everything in the rendering as well. And usually a lot of graphics library synchronize everything in the rendering. So yeah, it probably makes sense to do that here as well. So yeah, we're gonna put it like that. Delay time in milliseconds. So, and essentially what you want to do, you want to do automata render begin rendering. So we'll begin the rendering, and then we're gonna have automata end rendering. And maybe it would make sense to actually wrap all of that in curly braces, so we can clearly see this sort of section in here. So another thing that I would like to abstract away is handling events. But on top of that, I also want to be able to handle my custom events, right? So, and the idea is going to be the following. So we're going to have automata poll events, and we're also going to take a function, sort of the callback, like a custom callback that will handle things for the user, some special things for the user, right? So it's going to be something like a callback, and it will accept the pointer to the event. It will not be allowed to modify it, but essentially we're gonna move this entire thing, maybe not even that one, but this one in here, right? We're moving it in here. That was really weird. And after we handled the event ourselves, we're also gonna put it into the callback. Right, we're going to put it into the callback, so we have an opportunity to handle it, but we're only going to do that if the callback is available, right? If you have a callback, only then we're going to use this callback. So we're going to give you an opportunity to skip that, right? And then you can do automata handle poll events. I think I called it poll events, and I can just put null in here saying that I don't really care what you do there. Just do whatever you want. Hello, Sethu, welcome to the stream. Привет. Привет, привет. Okay, so, and for example, if you want to be able to pause, this could be something that you do in a custom callback. All right, that's pretty cool. That's pretty cool. Do we need anything else? I don't think we need anything else. I guess that should be it. And let me try to compile this entire stuff. So how many other SDL things we have? So here's the SDL renderer, and we passing it around all the time. Okay, so let's do a compilation of our nation. Is it compiling? It is not compiling. This one is not a pointer. Anything else? And window is taken from the global as well. All right, do we need anything else? I don't know why I assumed everywhere that it's a pointer where it's clearly not. Right, when it's clearly not. Okay, it's gonna be global quit, and I just do global quit in here, and global. Oh yeah, so I see. Cool. The only reason why we need to pass this renderer around is because we don't have a special wrapper that fills a rectangle. So let's create this special wrapper. So it's going to be something like automata fill rect, right? You don't have to provide anything special. What you have to provide in here is, let's say, float x, float y, float w, float h, and uint32 caller. So, and this is what we're gonna do in here. So this is the rect, and I guess in here I will have to actually put all of that like this, right? And then florf all of that. It's gonna be cool. So I do something like that. Then I provide the color. Then I provide the rect. Okay, so that should be okay. So we have a automata fill rect, and then I need to use it. Did I screw it up? So I feel like I removed some of this stuff, but I should have not removed it. Should have not removed it. Yeah. So essentially, I will need this information. I will need this information. Okay. So let me see. So it's gonna be automata, fill rect, and what color do we use? We use the cell color. I see. So we use the cell color. So the first one is gonna be actually just I cell width, right? So I cell width. So then we're gonna have Y, then it's gonna be cell width, then it's gonna be cell height, and we're gonna use the cell color. We're gonna use the cell color like this, and I can remove all of that. It's not needed anymore, hopefully. So that's really strange, but can I now make it a little bit prettier? Making things a little bit prettier is kind of difficult in a modern development tools, but I'm trying really hard. And now I can do a global renderer, and we can continue. Okay. So, and because of that, we never have to provide this renderer anymore, because we essentially taking it from the global. But yeah, I need to copy paste that because it will be not available, and I need to put this below a global, otherwise it won't be available. And let me quickly see. So render row should be okay. And now we're gonna go through the compilation stuff, right? We're gonna go through the compilation stuff. Conflicting types. How is this conflicting types? Oh, no, this is not conflicting types. Previous definition. Wait. Did I already have that? I got fucking damn it had that already. Ooh, I already had that. Fuck. Panapudi, hello. What happened to your hair? I can see them. That's a really strange question. Hello, Banana Wave, YouTube. Hello. All right. So, well, yeah, I haven't shaved for a while because I've kind of been depressed recently, so I had zero motivation to shave my head. If that's what you mean. Sorry. I'm gonna shave it eventually. Alright, so I need to do something about that, so maybe I'm gonna actually put an underscore here, and just make it a little bit easier to work with. Alright, so now I don't have to pass this entire thing, so I can just remove render. Yeah, using global variables actually simplifies the code dramatically. I don't understand why people bash on the global variables. I think global variables are great. Especially for the maintainability of the code, if you know what I mean. Okay, so we don't have to provide this thing anymore. Okay. So I think everything is great now. I really like it now. Okay, so let's actually move all of this like extra code to the framework and reuse it everywhere. So so it's gonna be automata.h, and yeah, I'm gonna just start moving things around. It's gonna be now here. So we have that. It goes here. And I'm going to move all of that shit, like literally to the framework. And I wonder where it is the best place to put. I'm gonna put it somewhere here. Fill rect. Okay, where's another fill rect? Okay, so here's another fill rect, which is irrelevant. We're gonna put this one here. And yeah, so the cool thing now, I think now I don't even have a single reference to SDL in this example. Look, I don't have a single reference, so we're completely abstracted away from the SDL. So, and we have a small framework specifically for these kind of examples, and basically do automate begin, you prepare everything, then you organize event loop, you poll events. It's not, we didn't completely abstract away from SDL. Essentially, callback still works with SDL events, but translating SDL events to some custom events is kind of like a waste of a time. And we also have a special section where you begin the rendering, you do the rendering, and then you end the rendering, and then you end the everything else. So yeah, and we can reuse this framework for several examples, and it will help us to standardize the look and feel of the examples. Alright, so let me see, so it doesn't compile because now in a render row, yeah, automata field, oh yeah, so let's quickly remove that. So it complains about this thing because it doesn't exist, and it should break goal now. Okay, so yeah, we ported rule 110, right? We ported rule 110, but we haven't ported the game of life. And by the way, I think if I just try to compile a rule 110, this not 100, but a rule 110, it will just compile, and you can always quickly check it if you want. And speaking of, now the speed of the next generation is shared between all of the examples because it's located in the framework itself, right? Because next gen timeout, for example, I can make it tenths of a second, I suppose, and it becomes faster. I can make it 100ths of a second, right? And it's gonna be super fast, as you can see. So yeah, and all of that is controlled in a single place, and changing this thing affects all of the examples. Pardon my ignorance, I understand shit about C. Oh, okay. So is the block below begin rendering just for having a better overview, or is it actually needed? Yes, it's for better overview. So C has these scope blocks that semantically do almost nothing. Almost. They actually do one thing, but they do almost nothing. So essentially, I can at any point just wrap this thing in this block, and technically will nothing change. The only thing will change is that this variable now is not going to be visible outside of this block. You see? So the C has the notion of the scopes, right? And scope is defined by the curly braces. By introducing curly braces, you actually limit the area within which variables defined here are visible. So this variable is only going to be visible within this block, starting from the beginning of the definition up until the end of the block, and it's not going to be visible here. Sometimes it's useful if you want to duplicate the names, you can just wrap them in separate scopes and don't think about it. Yeah, but here I added it just to visually separate the block of rendering. Alright, so but here we don't need to do that. Funkchi, hello, welcome to the stream, Funkchi, how are you doing? Alrighty, so what do we have? We have this shit. So now I want to make the goal also compilable. So let's try to make the goal compilable. So yeah, when we render the board, we don't have to provide the renderer, and we don't even have to provide it in this particular function. Nothing is required to be provided here. So when I render board, I just render the board and nothing else. And yeah, we also have invalid render. And this is because we don't have to do that shit anymore. What we have to do automata begin, right? So here's automata begin, and then we have to do automata end. So yeah, initialization and deinitialization. Cool. So here we don't have to do that. We can just do automata poll events. We don't have an event handler in here. Fuck that. So this is begin rendering. This is where we just begin the rendering. And the bot, hello, welcome to the stream. Automata begin rendering, right? And here we're gonna have automata end rendering. And I'm gonna wrap everything in the block as well, like this. So, and probably this kind of stuff should be put behind this thingy. And I'm thinking, you know what I kind of want to do? I want to kind of move next gen timeout into the global state of Automata, right? Into the global state of it, so all of the examples can share this entire thing. And yeah, that sounds like a pretty good idea. Automata's new array leap? No, it is not a new array leap. So, but what's gonna be the easiest way to do that? All right, so let me see. I'm gonna put the next gen timeout into the global state in here, right? So it's gonna be like that. It's gonna be initially like this. So when we pull events, here is the events, and then another thing we can do, we can take the global state. And next, how is it called? I forgot how it was called. Yeah, it was called next gen timeout. Yeah, next gen timeout minus delta time out in seconds. All right. Delta time out in seconds. And here's an interesting thing. We can, before trying to do that, we can check if this thing is less or equal than 0, and then reset it back to its original value. And its original value was what? Next gen timeout, like this. And essentially now, you don't have to check this stuff yourself. You can just remove that and do global Automata next gen is next gen, right? So we're gonna have a special function that checks whether it's already a next generation, right? And essentially how it checks that, it just does global next gen less or equal than 0, right? So something like this. And yeah, so that's the whole framework. You start this entire thing, and you don't even have to maintain this variable anymore. You just don't have to worry about that. So what you have to worry about is your own, you know, update and whatnot. So next row and next render and so on and so forth. Okay, that looks cool. So in here we put the gliders. Then essentially here I can say if Automata is next gen, we're gonna put it like this. There we go. So that should compile now, hopefully. And it doesn't compile because we don't have a global. Oh yeah, I keep forgetting that it's not an error. I don't know why I keep using this as an error. It's kind of annoying, but this is because I'm gonna blame C on that one, right? Because in C there's this annoying thing that you have pointer to the structure, you have to use one syntax. If you don't have a pointer to the structure, you have to use a different syntax, and it just, you know, you keep forgetting about that, and it's super annoying. Right, Automata time to quit. If it's not time to quit, we're gonna keep iterating, and there we go. So as you can see, now it goes brrr, and furthermore, right, we can change the speed, and speed is automatically updated across several examples. The same speed is used in all of them, right, because they use the same framework. Right, and that framework actually helps you to calculate when to generate a next generation and so on and so forth. So we basically took a lot of code and we abstracted it away so we can reuse it in the examples, which is cool. I think it's cool. And we can even, yeah, Now I can introduce the pause functionality without even modifying any of the examples. This is actually super cool. I really like this idea. So essentially what I will need to do, I'll need to add a simple handler in here, right? That just pauses everything and stop updating next gen timeout when things are paused, right? And it will be automatically available in all of the examples because they use the same framework, right? So yeah, that's cool. So we're not trying to like implement a general purpose framework, right? We're trying to implement a framework specifically for developing examples for automata. You see what I do here? Right. So essentially, it's kind of similar to the engine situation, right? People say that developing your game engine is so hard because when they say that, they're thinking about Unity or Unreal Engine because these engines are very general, right? And of course, developing something like Unity or something like Unreal Engine is hard, but majority of the time, people who implement their own engine, they're not implementing a goddamn Unity or Unreal Engine. They just don't fucking do that. What they do instead, they're implementing a very small, very simple engine, which enables developing only their specific game. In their engine, it's literally impossible to develop anything except that game. And such engine is easy to implement, actually. Way magnitudes easier than implementing Unity and magnitudes easier than implementing Unreal Engine. And this is exactly what I'm doing here. I'm not implementing some sort of like a general graphics library. No. I'm just implementing a framework in which you can only develop examples for these goddamn useless projects that nobody's gonna ever use in my entire life. Right, so, and that is actually super easy and that is actually very pleasurable because now I can just add like pause functionality and the pause functionality like works across all these examples and that's goddamn cool. But it's not applicable anywhere outside of this project and that's fine, that's kind of the point. Hello Jiak, welcome to the stream. How are you doing? Welcome. Cheers. Alright. So, let's see. What do we have here? Let me see. I wanted to commit everything. So what exactly did I do here? I essentially extracted the extract the common code between examples, the common code into a simple framework. Right, I'm gonna push that into the repo. Alright, so now I'm not gonna modify any of the examples, I'm gonna go straight into the framework and into the handling events, right? So into the handling events, and there I'm gonna just do the following thing: case SDL key down, right? So this is the SDL key down, and then I'm gonna check for event key sim, right? I think I also need to switch upon them as well, right? It's gonna be case SDL key space. I think I have to do the space thingy. Here's the space thingy. And when you press space, what we need to take global pause and we need to toggle it. So we need to toggle the pause. There we go. So we toggle the pause. And essentially we're not updating global next gen timeout if it's paused. So if global paused, not paused, only then we're trying to update all of that. And I'm going to introduce the pause variable into the global state. There we go. So now I'm going to I forgot to recompile everything. Right. So let's try to recompile everything. And yet again, I forgot that it's not a pointer. It's kind of difficult for me to keep track of that. It's not expose. And let's take a look. So I didn't update any of the examples. I only updated the framework itself. And now if I try to execute goal, right, it goes brrr, but if I press space, it pauses. And I didn't modify this example at all. I only modified the framework. So now I can pause, and then I can do another thing where I try to run rule 110. I press space, it pauses. I press space, it unpauses. It's pretty cool. It's pretty cool. I think I can even go further, but I'm not 100% sure if I can go further. And implement functions that let you paint specific rows with specific colors and whatnot, but what if we're gonna work not with you know, squares and whatnot? Hi, I usually lurk, but have you ever thought of making something like chess AI in the future? I don't find it very interesting. First of all, I don't like chess. I'm too dumb for chess. And I was never good at chess, so I don't hold any sentiment for that game at all. Like, I literally don't care about that game. So this is the first thing. Second thing, I think AI for chess is actually kind of boring, because at the core of AI for chess, what you have a graph, right? So any state of the game is a point in a graph, and transitions between the states are just edges. So essentially AI are different ways of traversing that graph, including using something like deep learning. It's just like a different ways to cut on different ways of traversing the graph. And I just don't find it interesting, I'm sorry. Yeah, I'm too dumb to play chess, I don't hold any sentiment for that game, and I don't think developing AI for chess is that interesting of a problem. Does it make sense? I'm really sorry if that offends anyone, but that's just my opinion on chess generally. Alright, so let's do the next thing. Okay. Introduce pause mode, and we're gonna push that right into the repo. So what's gonna be the next generation? So let's actually make it maybe like half of that. And I keep forgetting to rebuild everything. So that looks okay, but what about goal? What about goal? Goal looks okay as well. It goes brrr, goes brrr. I wonder how many of the of the gliders we can put in there. So we actually step in 4, right? And I can do something like 0, 5, right? 0, 5. And I can just do it like that. 4, 4. Right. So let me see. And now we have 5 of them. And what if I want to put 10 of them? Can I do that? I can do 10 of them. Look at that. Look at them go. Amazing. Absolutely goddamn amazing. 20. How about 20? I feel like at some point they will start colliding with each other, maybe. So I don't remember how put glider at is implemented. Does it wrap around appropriately? Oh yeah, it does wrap around appropriately. So that means I can actually create a situation when they will overlap with each other. They will overlap with each other. Okay, so that actually created like a perfect line of them. So it's kind of cool how they wrap around on the edges in here, right? So yeah, that's pretty funny. Oh wait, if they're actually with the intervals, with the regular intervals, so that means it should probably paste them. Yeah, so even if I make like 100 of them, it's probably not gonna affect anything. Oh shit, that's very interesting. This is because like this function paste them at regular intervals that are synchronized. So when it wraps around, it basically pastes glider on top of the other glider, which doesn't break anything. That is actually very interesting. So that means it's probably because the sizes are even. What if we make the sizes of the board odd? Is that a thing we can do? So where's the rows? For example, instead of 100, we can make it 99. We can try to make it 99, and let's see. And there we go. It actually broke. Right. So yeah. So basically, they distinct from that, and now we have this kind of shit. That's pretty cool. I'm not gonna lie. It's pretty cool. I wonder if it's gonna stop at some point. Or is it gonna continue? Oh, it actually spawned the glider. And we can stop at any point. Cellular Automata, yes. And... okay, so... yeah. I wonder if it would be possible to control the speed somehow. But yeah. Okay, so what do we got? Maybe I'm gonna actually... yeah, I think I'm gonna just remove all of that. Did I actually push everything? I think I did. You know what would be cool? It would be kind of cool to also keep track of the screenshots. Like every time we implement a new automata, we could paste a screenshot. But I'm not sure. Yeah, at some point I will probably change the theme, so that will mean that I'll have to recreate screenshots. So I'm not going to do that. All right. So let me take a look at the automata repo, and let's take a look at some other cellular automatas. What other things do we have? History, elementary, chemical types, biology, modern physicals. Okay, so I think I saw some interesting tomatoes somewhere down below. So this is just a reference, like yeah, Brian's brain. I think I remember this one. Yes, so this is how it looks like. So it's almost like Game of Life, but it actually creates a very interesting distinct patterns. And for this specific one, the cell can be in 3 states. It's not 2 states, it's actually 3 states. So the first state is dead, dying, and alive. Gas modeling is cool. Maybe, never try that. So, devised by Brian Silverman, which is very similar to his seeds rule. Alright, so let's see about seeds rule. Seeds rule is cellular automaton in the same family as the Game of Life, initially investigated by Brian Silverman and named by Mirek Wojo. I don't know how to pronounce that, but this is actually fucking crazy. It consists of infinite two-dimensional grid of cells, each of which may be in 1 or 2 states on and off. Each cell is considered to have 8 neighbors, as in life. In each time step, the cell turns on or is born if it was off or dead but had exactly 2 neighbors that were on. All other cells turn off. Thus, in the notation description family containing life, it described as the B2S. Wait. Each cell considered to have 8 neighbors. In each time step, cell turns on or is born if it was off or dead but had exactly 2 neighbors that were on. All other cells turn off. Is that it? This is actually simpler. This is actually simpler than Game of Life. Right, so it's dead, and if it had 2 alive neighbors, it becomes alive, and everything else becomes dead. You pronounce it Mir. Okay, Mirek is short for Miroslav. I see. Alright, let's try to implement that. And I wonder if we can essentially reuse a lot of stuff from the Game of Life, right? So Yeah, maybe eventually this entire thing will turn into like a framework for like two-dimensional tomatoes. So that would be kind of cool. Alright, so, but until then, I'm gonna duplicate code. So we're gonna have seeds, and I'm gonna just include a tomato. H. This is not how we do that. So, yep. By the way, if anyone knows any other interesting cellular tomatoes, feel free to suggest them. Polish guy, yeah, is that is that something unusual? Population of Poland. We have like 38 millions of them. Like, doesn't sound like that unusual. So I don't know. Just saying. Anyway. Oh yes. Okay, let's calculate the chance. 37, 38. Okay, multiplied by. So this is a million, right? So this is a million, and 7 billion is gonna be something like this. It's actually gonna be a very small chance, literally zero. It's actually a very small chance. Look at that. It's less than 1%. Okay, so I take everything back. Maybe it is unusual. Funk-Chi, please vanish yourself. Oh, no, I'm gonna vanish myself. I'm an idiot. Yeah, it's a 0.5. Okay, I'm an idiot. Yeah. I'm sorry. I need tea. So, alright, does anyone have any... Okay, somebody already suggesting Wire World. Wire World. So, okay. So, first proposal, Brian. Wait a second. Is there anyone except Conways and Brian Silverman who's actually doing all this kind of stuff? Or is like there were only two people? This is interesting. Okay. So, well, rest in peace, Conway. But so that means we have only one dude who's doing all of that. This Brian guy is pretty deep into this kind of stuff, it seems. Yeah. Let's guess atomic. I would really appreciate the actual links. So does anyone have like any links to Wikipedia article or any kind of article that explains the cellular tomatoes, and we can implement them? So, okay. So I'm sorry that bot actually timed you out. You're probably new here. So, but I still have the link. Don't worry about it. Okay, that's pretty cool. Okay, so I'm gonna actually trust you. There we go. And so there we have also Langton's. Holy shit, that's so cool. Two-dimensional universal Turing machine. It's a very simple set of rules, but complex emergent behavior. All right, I really like that. Okay, so let's actually do a small to-do in here. Where I'm gonna actually put all of them. Tomatoes. So we're gonna have something like this. So first we'll have a rule 110. Then we have Conway's game of life, and then we're gonna have. So another thing I want to implement seeds. Right, we're gonna implement seeds. I really want to implement that one. Then I want to implement Brian's brain. Brian's brain. The gas one, yeah, the gas one seems actually pretty cool. So wire world. Okay, so oh yeah, so we need to also trust blue. And what is gas automation? So also and okay. So I think that should be enough for us for today. So thank you everyone who suggested all of these things. We're gonna try to implement them. Langton's and all right. So rule 110 for rule 110. Oh, I already had link in suggestions and I completely missed it. So this one is actually implemented. Conveys game of life. Conveys game of life. Also implemented. Cool. All right. So add to-do list of tomatoes. And there goes my PR. Did you submit the PR? Let me check it out. I have a lot of notifications, but I didn't go through them for quite some time already. Oh, you didn't submit. I see. Okay. All right. Let's make a small break, actually. We're saying about creating para to add links to the rule. Zozin, your readme is unfinished. Okay, so let's make a small break. Have fun. Yo, what's up? Epic Gamers? How's it go? Welcome back. So We introduced a seeds. So now, check my PR, thanks. Did you submit the PR? If it's a debate, you're getting ignored forever. Fix typo, okay. Oh, okay. Alright, that makes sense, sure. Thanks for fixing it. Cool. There we go. Thank you so much. So let's actually fetch it. Yep. All right, so what do we got? Seed, right? We need to have seed. So we do automata begin, right? And then we do automata end, and that's pretty much it. So it creates like, you know, initialization and deinitialization. So while automata time to quit, we're gonna keep doing these sort of things. Oh, by the way, my kettle is ready, so I'm gonna quickly pour myself a cup of water, and I'm gonna be back, just super quick. What's up? Ah! It was too hot. That's hot. That's hot. Ah. Alrighty. So, man's that hot. Yeah. Yeah. Sorry, I don't know how to do that. So time quit, and we do automaton poll events. Then we also calculate the next generation, but we don't really have any generations. So the only thing I'm gonna do, automata begin rendering, then we end rendering, and there we go. So this is where we can do all of that, and this is the whole boilerplate, seriously. So, and that creates you like a new ready-to-use example where you can have your own events, you can have your own update, and so on and so forth, rendering. So it's pretty cool, really like that. So the only thing we need to do here, we need to add this entire thing to the builds, and maybe I can use like wildcards, the GNU wildcards. Yeah, I want to use them, and they're probably not going to work on FreeBSD. And I need to ask myself a question: do I care? Do I really care if it works on FreeBSD or not? Well, to be fair, I can make it easily work on FreeBSD by just using no build, because I know no build works on FreeBSD. And this kind of job for FreeBSD is super easy, actually. It's actually super easy because you can iterate through all of the files and match files by their extension and do actions based on those extensions. Yeah, so it would be, and you get like a FreeBSD support for free or something. Every time I use new make features, I see how Split's face cry. Alright, so at some point, yeah, so it's easier right now to just use GNU make features, and then maybe later we're gonna port it to no build. Later. Or maybe now, I'm not sure. I'm still not sure. Okay, so I wanna rename this entire stuff to just packages. So then I kind of want to move this entire stuff in here, and then this stuff to libs. Right, so it's gonna be libs. And now we just have C flags. So in here, if I remember correctly, this is how we do that, right? This is how we use the wildcards. So it will try to match this shit, and the output has to be like this, and the input has to be like this. Don't ask me how I remember that. Yeah, so essentially, this thing is equal to that, and this thing is equal to that. Yes, this thing is equal to that. Yeah. What's up, here, Watson Plus? What's up? Nice syntax. Guess how you're supposed to remember. Guess how we're supposed to remember this syntax. So, essentially, this is a target, and at looks like a target. Yes, at looks like a target. And less looks like a redirecting input into the program, right? So you're redirecting, so this is the input. You can remember this as an input because this is how you redirect in shell. And this is a target, and this is how you remember it. GNU, what the fuck is wrong with you? Well, I mean, it works. It works. You can remember. All right. So let's try to build this entire stuff and see how it works. So does it build everything? It seems to be building everything. No rule for seed. That's very strange. Do I have? Oh, it's called seeds. I see. It's called seeds. Alrighty, so, and it's something, doesn't complain about something, so boolean. I probably need to include stdbool here. Aren't build systems supposed to help developers? Doesn't feel like it's helping too much. Why it doesn't feel like that? Alright, so that created this thing, right? That created this thing. And here we go. Here how we quickly created a new example in here, which is nice. So now I need to introduce the board. Right, it's going to be type dev struct board, and we're going to have a bunch of cells. It's going to be cells, rows, calls, and it's going to be type dev enum cell. And according to the description that we have in here for seeds, they can be on and off. So I suppose off is going to be 0 and on is going to be like 1, right? So this is how we achieve all of that. This is how we achieve all of that. And let's introduce like something like void next board, which accepts previous board and should return the next one. To the next one. All right. So, and we need to implement that rule. So the thing that actually kind of worries me is that, well, not really worries me, but makes me think is that there is a lot of duplication between Game of Life and Seeds implementation, and I keep thinking, can I just reuse a lot of the code from there? But that duplication basically means that they're from the same class of the games. But what if we're gonna have like a hexagonal game, right? None of the code for Seeds and the Game of Life is gonna be reusable, right? So yeah, but maybe we're gonna have like a reusable code for different classes of games, like two-dimensional game, hexagonal games, and maybe three-dimensional games or whatnot. So yeah, we'll see how it goes. So first I'm gonna pour a cup of tea. I'm gonna implement that. It would be kind of cool to have a framework where you only have to specify the rules for like calculating the next cell and everything else is reusable. But we'll see how it goes. Maybe it will evolve into this kind of framework. But again, it's not reusable, for example, for rule 110. For rule 110. Mm-hmm. Hello, Mizi Mizi, welcome to the stream. Hello, hello. Okay, so we're gonna do the usual thing where we iterate through this stuff. I kind of want to introduce a snippet for 4 because I had a snippet in my other mode. Maybe I need to introduce it for nothings mode as well. Yes, new snippet, and it's going to be 4. Key is going to be 4, and it's going to be something like this. So we're going to have initialization, condition, and next. I think it's something like this. I think this is how we do that. So then 2, then 3, right, and then you put it like that. So should kind of work, but I don't remember if I have to escape this entire thing. We're about to find out. So this one is going to be 4. Yeah, create everything, and I'm gonna reload just in case, and I could do something like that. Okay, so that makes sense. 0 less than rows plus plus I, and I think I should be actually called row. I think it would make a little bit more sense in this particular case, or maybe even further, y, right? Something like y. But I don't kind of like the fact that it loses the indentation, if you know what I mean. Like, let me show you, like this. It kind of loses the whole indentation, and it kind of, I don't know how to make it better, but you can always like restructure it. Maybe that's okay. That's totally okay. All right. So let's introduce another one. It's going to be int x, x less than columns plus plus x, and then we're going to do this kind of thing. So we also need to count the neighbors, right? We're going to do something like this. It's going to be, how did I call it in goal? Neighbors. So board neighbors, let's actually call it like that as well. Board neighbors. It's gonna be board. I already automatically call it row and 0, and because of that, maybe it would be better to still call it row 0 or column 0. So yeah, so we need to do the rule, right? So if the cell was dead, row column, but it's called on and off, but then they use dead. All right, so that makes sense probably. Off. If it's off, next cells. And we need to calculate the amount of neighbors. Board neighbors. So I provide the previous board row and column, right? I provide previous row and column. And if amount of neighbors is equal to exactly 2, this thing becomes on. Otherwise, it becomes off always. So that's the whole rule, essentially. That's the whole rule. Let me see if it compiles. Okay, so const. Okay, so there's a couple of warnings, but warnings are just from the unused variables, nothing special. Cool. So, and let's just calculate the neighbors. All right. So it's gonna be something like d_row -1 d_row 1. It's gonna be like this. Dcall -1 dcall less than 1. And yes, so only if d_row not equal 0 or dcolumn not equal 0, we're gonna do int row 0 plus d_row. So, and if board cells row call equal on, we'll increment the result. So then I'm gonna actually put this entire stuff here. So here's the result 0, and we're gonna return result here. There we go. So we have a function that does everything we want. But we also need to render this entire stuff. We need to render that board. Hello, Agadu, welcome to stream. Render board, const board. So it's gonna be a row less than rows, and it's gonna be column less than calls plus call. And how are we gonna do that? So yeah, we need to use the fill rect thingy. Automata.h fill rect. So this is what we're gonna use here. Okay, so here's the x. I'm gonna multiply it by cell width. So the y is gonna be basically, no, it's actually call. Then row by cell height, and then we can just use cell. Cell width and cell height. Cell width and cell height. And we can use the... Where do we use the color though? Do we have the foreground color somewhere? Right. I'm pretty sure in goal, when we render the board, right, when we render the board, okay, so it's hard-coded. Let's actually set this thing to some sort of like a foreground color. So I'm going to define it like this. Background color is going to be foreground color. So this is a foreground color. And yeah, in here, I guess depending on whether it's dead or alive, we're going to use either foreground or background color. So board, I don't know why I called it border, it's just accidentally, of course. Cell row column, if it's equal to on, this is going to be foreground color, and this is going to be background color. So that should be it. And let me see what's going to happen if we try to use that. It's called cells. Okay, so maybe it would make sense to actually introduce like cell colors, similarly to how we have that in goal. So it's going to be uint 32 cell color. Let's have 2 of them, and then we do something like off is background color and on is foreground color. There we go. So then here I can do cells cell color like this, like that. There we go. Cool. But I also, okay, so it doesn't really work because if I go to semicolon, right, if I try to run the seed, right, it doesn't really do anything unless, I guess we need to generate like a random board, right? So we need to generate a random board. Let's quickly try to do that. Generate a random board. A random board. Oh yeah, I didn't even organize the switching between the board anyway, but I mean, it makes sense to actually generate a random board anyway. Random board, and So it's going to be int row 0, row less than rows, plus row, int column 0, column less calls, plus call, and so in here we're going to do board cells row column it's going to be random between these two. Right, it's going to be random between these two. So, and it probably makes sense to introduce like two boards in here. So board 2, both of them are 0 initialized, and you keep track of the foreground and background one, right? And then you essentially take the foreground one and initialize it with random stuff, right? So there we go. Here's this randomly initialized thing here. Then if automata is next generation, when it's time to calculate the next generation, what we're doing essentially, we do a next board. Let me see. Two is going to be board fg. So we also need to calculate the background one. So background is going to be minus fg. This one, we're moving it into the background, and then the foreground becomes the background. There we go. And a render board. So, and the board that we are rendering effectively is this one. So always the foreground. So we implemented this entire thing. All right. So let's see if it's gonna work now. Well, I didn't recompile it though. Seeds. So this one has to be also a pointer. This one is interesting actually. It probably looks like shit. So let's try to see what we can do here. You know what I want to be able to do? I want to be able to actually click on cells and switch them on and off, if you know what I mean. Switch them on and off. I think that will be actually kind of cool. Right, and that will mean that we need to have like a custom event handler for poll events, but shouldn't be that difficult to implement if you ask me. All right, let's actually make this entire process slightly slower. Next gen, let's make it like half of a second so we can appreciate and see how the seeds are moving. So this is how essentially they are moving. It's actually pretty cool. It creates a lot of interesting gliders. I'm not sure if you can see some of them, but yeah, it literally creates a lot of gliders. And the only reason why it looks like a mess is because we have too many of them. Right, so yeah. Let me implement the functionality that that lets you click on things and modify them. I think that will be kind of cool. All right, so I'm gonna git ignore seeds. Right, we're git ignoring seeds, and I'm gonna literally introduce the seeds example. Add seeds example. Let's push that right into the repo. Hello, Monica Live. Welcome to the stream. All right. So let me see what I want you to do. Yeah, I want you to have a custom handler there. Want you to have a custom handler. Let's quickly do that. Seeds.c, and the custom handler should have an access to the global state in here, right? So let's call it seeds event callback. Seeds event callback, and this is what we're gonna do here. So it's gonna be switch event type, and it's gonna be case. And what we're looking for, I suppose, we're looking for the mouse down event, right? So it's gonna be something like SDL mouse down, right? SDL mouse down. And in here, I forgot what we're looking for. So the event SDL mouse button down. Yeah, something like that. Haven't been here in a while and surprised by the new cut, but it looks sharp. I hope you're well. Thank you. So yeah, so here's an explanation. So how many times times CMD hair, how many times we had to issue this command? Yeah, we are actually approaching 1000 times. I cut my hair several months ago and I had to explain why almost 1000 times. Literally. Not exaggerating. I'm literally had to explain that almost 1000 times. We had like exact concrete number. So yeah. Nice. Anyways. And this is like the scariest part is it's not exaggeration, it's like literally almost 1000 times. Yeah. Okay, so essentially I think I had to do something like it has to be mouse button downward. You didn't explain this time. I mean, by explaining I mean issuing the hair command. All right. Yeah, the compiler will tell me about it, don't worry about it. And I'm sorry that bot actually recognized you as a link. Well, welcome to Tsodin channel, I suppose. Alright, so... Yeah, look, I'm gonna show you. Look. Compiler just told me, so... Oh shit, okay. Let's continue. So, what I want you to do, I want you to take a look at the buttons, right? So, event button X, and what I need to do to detect the cell we're at, we need to divide it by cell width, right? And then floor fit, and then constitute an integer. So, and that gives us a column, right? That gives us a column at which we currently are. And then to take a row, we have to use Y and height. Are you guys trying to get it to 1000? Okay, sure. Okay. So then I take the board FG, cells, row and column, and essentially I guess I flip it, right? So that's how we do that. We just flip it and whatnot. And I'm not gonna generate anything in here, right? I'm not gonna generate anything. Yeah. Oh, since being posed is a functionality of the framework, it would be kind of cool if the framework would also somehow visually indicate that you're currently posed, like, because in the end of the rendering we can inject our own rendering things, right? So for example, if you're in a posed mode, we can inject that some sort of like sign that says we're currently posed, and the user of this library never have to code that themselves, right? I think that's actually pretty cool. Anyway, and we also have to provide the callback. I completely forgot that. When you poll event, you can also provide your own callback to, you know, handle some things in your way if you want. Alright, so now I can click on things and I can actually add them here. And then I can resume and it starts doing things. Holy shit, this is seeds, by the way. This is not a game of life, this is seeds. And this is very interesting. Yeah, it emits this glider. Okay, so here is the easiest glider you can make. This is it. This is the glider. It creates a lot of gliders. Huh. That's so cool. And the rules are way simpler than Game of Life rules. What the fuck? And it just creates more interesting patterns. And it keeps growing. It actually keeps growing. It creates a shit ton of chaos and stuff. Huh, I like it. We probably can make it even faster. Right, so where's the next gen? Let's make it like 10 times faster and see how it goes. Alright, so we're gonna create just a quick glider, and it will just move around like that. So... it doesn't wrap around, really? I forgot to code wrapping around. I think I forgot to code wrapping around. So yeah, I literally forgot to code wrapping around. Just a second. So here's the neighbors, and when I do plus, what I just have to do is just mod for rows and mod for the columns. Mod for the columns. Okay, that looks cool. Now, okay, so I have to do it like that. Will this be okay? Holy shit! This thing is dangerous. And like it's such a simple. It's simpler than Game of Life, and it gives such a weird results, and I really like it. So we also need to be able to somehow like clean the board. We need to be able to clean the board. Case SDL key down. On which key we should clean the board, by the way? Does anyone have any suggestions? Escape. So something like escape. Yeah, that's escalated super quickly. And the rule that we implemented, by the way, for those who just joined, seeds, right? It's a seed cellular automaton. All right. So R sounds okay, I think. So basically refresh. If event key sim equal SDL key R, right? We're gonna just take the current board, so foreground. So FG stands for foreground and BG stands for background. Basically, I have two boards, foreground and background, and I compute the next generation to the background board, and then I swap them. So it's sort of like a double buffering, but for the boards, if that makes any sense. Yeah, because you need to retain the previous board to calculate the next one. A refresh in case of sig-il. Nice. Sig-il. Okay. So cells, and maybe I'm just gonna memset them. Memset them to 0. Size of a single cell. Cell multiplied by rows multiplied by columns. Alright, so this is basically what we do here, and that will clean everything. So, okay, so I think I can reproduce that. It was something like that. There we go. Okay, and at any point I can just press R and it actually cleans it. So I can just put a bunch of things in here, and it also generates a lot of different things. Yeah, so that's seeds. That's a seeds for you. Do we need to implement anything else? I don't actually know. Yeah, encoding actually goes to hell completely. You know, I really want to be able to draw the text that says, you know, posed when you actually pose, but that needs to be done by the framework itself. And if we want to draw the text, we need a font. So I'm probably gonna use my pixelated font, not my pixelated font, but the one that I use in something. So I'm gonna actually port it in here. I think that's what I'm gonna do. This one is going to be very interesting because I don't want these examples have runtime dependency, so that means I'll have to bake that font into the executable. So yeah, we'll have to do a little bit of a cleaning up. Yeah. So essentially, basically the idea what I want to have, right? Right now, for example, how can you tell if the game is posed right now or not, since it doesn't have any frame of reference, right? It doesn't literally have anything. The only way for you to know is just to place a thing, and if it disappears, that means it's posed, right? But that's not particularly convenient. And we want to be able to have some sort of visual cue, like a big sign posed, right? And we want this to be available for all of the examples, and that's what I'm going to be working on right now. All right, anyway. So maybe we can actually start in a posed mode. Maybe not, I don't know. Right. So what did I do here? Add drawing capabilities to seeds example. It would be cool to be able to share them, but I'm not sure. Anyway, you can find the source code here. You can just draw two rects as pose symbol. That's a good idea. Yeah, I think it's gonna be easier to communicate. Yeah, I don't know why I wanted to have a text. Yeah, let's just draw like two rectangles. Yeah. So automata and rendering. So here's the render. Where is the rendering? Rendering and rendering. So this is where we can do all of that, right? So as a user of the library, you have to first call automata begin rendering and then automata end rendering. And this is where we're gonna inject this kind of thing. So if global is posed, we're gonna draw that additional stuff, right? That additional symbol. So let me see how we're gonna do that. First, we need to know the offset, like the padding. You can create the concept of layers. Layers could be static automations all the way down. Maybe. I'm not sure. I'm trying to not complicate things right now. Right, I'm just implementing as I see fit, and then when I see the patterns, I'm extracting them to abstractions. So, yeah. Yeah, I think it's easier to work it this way for me. Alrighty. I need to make a small break, just a second. 2 minutes. Let's make a small break. And you guys have fun. Hello, welcome back. All right, so let me see what we can do here. Pose padding. So we need to have some sort of a variable that controls the padding, because we're going to be drawing it left top corner, right? Hello, script SH. Left top corner, and we definitely need some sort of a padding. So if we have something like a screen, so here's a screen. So the pose is going to be probably drawing somewhere here, right, like this, in this rectangle, and this is the padding. Maybe we're going to use the same padding for both vertical and horizontal. I think it's going to be easier. And also we need to have a lot of other constants, like the thickness of these things. It's kind of strange how it works. I don't quite understand how, but yeah. So we need to introduce all of these magical constants at some point. All right, so if it's posed, maybe we can do something like automata draw pose symbol, and it will accept maybe the position, right? And the position is going to be literally pose padding and pose padding in here. So I think that's the easiest way to go about it. And let's see. Automata, draw pose symbol, X, Y. All right, so padding is going to be like around this, then pose height. Let's say that is going to be around 100. I'm not sure, since I'm going to be using the rectangle, so I might as well actually use floats in here because I have a special function that will then convert those floats to integers. I don't have to think about that. So pose height and then pose bar thickness. It's going to be around maybe 20. Pose bar thickness. Maybe this one could be pose bar. Yeah, if we're going to do it like that, it could be just pose bar width and pose bar height. And we can do pose bar gap. So the gap between them. The gap between them could be similar to their width, but all of that can be adjusted in the future. All right. That's cool. So, next thing. Automata. Okay. Pose bar color. Should be something like a red, I think. Okay. And we're gonna put it like this. So fill rectangle. So fill rectangle has X, Y, W, and H. X, Y, W, and H, and the color. So X for the first bar is gonna be X and Y, right? And width and height for it is gonna be literally pose bar width and pose bar height. Pose bar width and pose bar height. So that's it. And of course the color has to be pose bar color. So this is the first bar that is going to be drawn. So, and then we need to draw the next one. And the next one is going to have the same size and the same height at which it's drawn. And the only difference is going to be is it has to be shifted to the right. So it has to be shifted by the pose bar gap. But this is not enough. There is also the width of the previous bar. So that means we have to add pose bar width. Pose bar width. And I think that is literally it. I think that is literally it. Yeah. So you draw two bars, and we have a small section that describes different parameter of the pose bar, pose symbol. Yeah, and you can control all of them. It's actually pretty cool. Let's see if it's gonna work. And it's only drawn when we're in the pose mode. So let me see. So cool. And yeah, it first tried it. literally first tried it. But the problem is that the padding could be a little bit bigger. I think the padding should be like around maybe 50. Yeah, I think around 50 should be okay. So yeah. So it could be like actually styled slightly differently, but I think this style is okay. Yeah, this style is okay. All right, and now we can clearly see. But unfortunately with this kind of style is that, like, how do I add things behind? How do I add them behind? Right, so maybe we have to make them semi-transparent. So, and I think we can do that through the alpha. What if I make alpha like 99? Is it gonna help? No, it does not help, because I think alpha is not working until you actually enable some sort of like a blending and whatnot. Alright, so SDL, I don't quite remember. I think I can just steal some of the code from the existing projects. Set, yeah, set render draw blend mode, and we're gonna do that here. So begin, after we initialized everything, we need to set the render draw blend mode from using the renderer, and this one is, I think, SCC. Yeah, SCC. Is it gonna work now? Yeah, as you can see now it's slightly semi-transparent and I can see things behind it. So yeah. Well, I mean, at least it's still a visual cue. It's still a visual cue. But it could be less transparent, actually. Bar color, maybe something like BB. Right, and we could put it like that. And then if it starts to do that, we can clearly see. But I mean, at the point when you have something there, you can already clearly see that you're already posed. So I think that's totally fine. Right, so yeah. Alrighty, so let's commit that. Add a visual cue for the posed state. Visual cue for the posed state. Do we need anything else? I don't think so. I guess I'm gonna declare this automata done. So maybe we should read more about it. This one actually sounds interesting. So it consists of infinite. We already read the rules. In a game of life terminology, a pattern in which all cells that were on turn off at each step is called a phoenix. All patterns in seed have this form. Even though all life cells are constantly dying, the small birth requirement for 2 cells means that nearly every pattern in seeds explodes into chaos, and into chaos mass that grows to cover the entire universe. Huh. Thus, in Wolfram's classification of cellular automata, it is a class 3 automation in which nearly all patterns evolve chaotically. However, some patterns are known to behave in a more controlled fashion, repeating the same shape either in the same position of the grid, an oscillator, or translated some numbers of grid units after several steps, a spaceship. More complex rake and puffer patterns are known, which move like spaceships, leaving trails of oscillators or other spaceships behind them. Most of these patterns move at speed of 1 cell per time step, those so-called speed of light. Interesting. Oh, okay. So there is like a terminology in like cellular automata enthusiasts, among the cellular automata enthusiasts. So if the spaceship moves with the speed of 1 cell per iteration, it's a speed of light because it's a maximum speed with which you can move in that universe. You see, this is actually such a cool reference, right? So it's a maximum speed with which you can move, like 1 cell per second, and that's why it's a speed of light. Right, it's a maximum that you can never like move faster. So yeah, interesting. Including 3 commonly seen patterns for each cells. Collection of patterns for seed rules collected by Justin Summer, including patterns found by. Okay, so is there like any website where we can take a look at some of the interesting patterns? Oh, so there's no even a website. It's literally like a zip file. Wait, really? So patterns are in a zip file? That's really strange. But this is a really interesting cellular automaton. I really like it. It's so simple, but yet produces very interesting results. So here's a zip file. So it's a bunch of leaf files. And what is a leaf file? Okay, so it's some sort of a format. It looks like RLE. Yeah, I think it looks like RLE, if you know what I mean. So BO, maybe it's like a dead or alive, but oh, interesting. So it also specifies the rules, and it probably also specifies the sizes. So is there any like software for Cellular Automata that can read this kind of format? Maybe there is, okay, maybe there is some sort of readme. And on top of that, this entire file is a zip bomb. This is a goddamn zip bomb, so it doesn't even have a special folder for it, unfortunately. So we'll have to create a B2S folder for it and actually move it here, right, and unpack everything in there. So I'm gonna do it like that. Okay. So, and is there any README? There's not a single README. So this file includes all patterns. Okay, I remember I saw a link to a software that is capable of simulating all sorts of cellular automata. I think it was called Golly. I think. Yeah, Golly Game of Life homepage. So, and maybe that's the software with which you can read these kind of things. Leaf? Huh. There's a lowercase readme. Okay. This is a pattern, exactly collection. It doesn't explain anything though. Alright, so search Golly. So maybe we can read this file with Golly. We do have that. Alright. Let's install it. So it's a pretty old software apparently, because it's available on Debian. Nice criteria for old software, right? So it's available on Debian, that means it's pretty old. Okay, so can we run it? Okay, nice. So it worked first try. Good software, by the way. Wow, wait a second. This is such a good software. I just ran it and it did exactly what I expected. Even though I heard it can simulate all sorts of cellular automata with different rules. You can specify your own rules and shit like that. But I just opened it and it by default did a game of life. And it worked exactly as I would expect it. This is so rare when a software chose right off the bat reasonable defaults. Well, what is going on? Encoding? It's probably because of the grid, I'm sorry. So, can I open pattern? Oh, okay, so, yeah, so it can open leaf files. This is actually pretty cool. So we can open the leaf files. So let me go here, and I'm gonna go to the programming, and this is studying, and we need to open Automata. Where is Automata? Here is Automata, and we can open some of these things. So which one should we open? I want to take a look at the rakes. Do you want to save? No. Okay, so here's a bunch of things. Can we... So, is that a single... Oh, that's... Holy shit, this is so cool. And it's so fast, by the way. Can you see that? Holy shit, this is so cool. And it's... Yeah, how is it so fast? I can actually move around. Yeah. So yeah, this is the seeds. And it's a rake. It just throws them around. This is so cool. And the software is so intuitive if you know how to work with cellular automata. Seriously, here's how to get what I'm doing. So you need Golly, right? I guess it's cross-platform. I don't know if it works on Windows. It must be working on Windows. Yeah, maybe there is a distribution for Windows. Is it more? I think they're all coming down. So I'm standing still. Yeah, so this is the screen is the point of reference. The screen is the point of reference, so they're both moving and up and down. So the main spaceship moves up and the trail moves down. So you need goalie, and in the page seeds, right, you go down and you get the collection of seed patterns. So we can try to open something else. So rake puff. All right. So let's take a look at this rake puff. That's so cool. But we're looking not into the build patterns. We're looking into the ones provided for the seeds game. That's pretty dang. Goalie is pretty cool. How do you come up with the sponsors? I don't know. So I guess you need to ask Brian Silverman, who actually did that. Apparently there is this guy who is a huge enthusiast in Cellular Automata, and he came up with all sorts of different interesting rules and different patterns in those rules. And apparently he contributed a lot into the Cellular Automata thing. He's a Canadian computer scientist and creator of many programming environments for children and researcher in Cellular Automata. Yeah, interesting. Cool. Because every time I Google something about Cellular Automata, his name pops up. So he's a really huge enthusiast in Cellular Automata. Alright, so this was seeds. And another pattern that he came up with is Brian's brain, which is slightly different. So the special thing about this pattern is that the cell can be in 3 states. Unlike in Game of Life or Seeds, where you can have only alive or dead cell, here you have alive, dying, and dead. So you have a gradient of, of this state. Not really gradient, but you have more states, essentially. That's what I'm trying to say. I wonder if there's I know that there are continuous cellular automata, right? So that are not on the grid, but rather the cells are floating point coordinates, have floating point coordinates. And because of that, you get very smooth, roundy gliders that move around and they look like literal cells. I don't know if I actually show that, so let me show you. I wonder if they also have continuous state. So I know that they have continuous position, but do they have continuous state? That's a good question. Continuous game of life. I'm not sure if I will be able to find something. Oh yeah, smooth life. This one. So it looks like this. So this is essentially cellular automaton rather, but it's continuous instead of discrete one. So I suppose they have continuous position and continuous state. And these gliders, they do look like cells. Yeah, it looks pretty trippy. So maybe we can implement that at some point as well. I don't know. We'll see. But that's pretty cool. Alrighty. So I'm gonna remove it for now. So you know what? When we run Game of Life, right? When we run Game of Life, we have a bunch of gliders in here. So maybe for the seeds, we also need to create a bunch of gliders that move around when you by default enable it. I think it's a good idea generally. Yeah. And by the way, if I rebuild everything, without changing anything and rerun Game of Life automatically has this pose symbol because it's part of the framework. Yeah. All right. Let me remove that. Okay. Seeds.c. Bolt membrane, no, I never heard of it. So add a put glider add. It's going to be board, and we can provide the row and column. Row and column. So so what kind of glider I want to have there? What kind of glider I want to have? So the simplest one looks like this, right? The simplest one looks like this, and what's interesting about this specific glider, it works at any direction. You can point it at any direction and it will move in that direction. So that's cool. That's what's cool about it. And oh, and a simple oscillator. So this is simple oscillator looks like this. Huh. That's so cool. And then you can actually put some stuff in here, and that will explode in chaos. That's so funny. Look at that. Like, you have like a simple glider, right? And just an oscillator. Holy shit. Alright, so put. To be fair, we want to actually point them at different directions, maybe? It's probably not even called a glider, but yeah. So to put it in a particular direction, that means we'll have to rotate and stuff, but I don't want to do that. So let me have a cell, and we're gonna have a glider, and the glider is gonna be, right, so it's gonna be something like this. All right, it's gonna be this, this, and this. So that means its size is 4 by 2, right? You have 4 rows and 2 columns, right? 4 rows and 2 columns. And let me quickly populate that. So it's going to be on and off, on and off, 1, 2, 3, 4, and boom, boom. There we go. I just encoded this pattern. It was kind of easy. We can also put it in static memory. So now I'm gonna be iterating through all of this stuff. It's gonna be d_row 0, d_row less than 4, then 4 int d_column, and d_column less than 2, plus d_column. All right, and initial values in here, I think they should be called row 0 and column 0, right? Because they're just offsets. And we're gonna have a row, which is an integer, row 0 plus d_row, and we're gonna wrap it around horizontally, and this entire thing should be wrapped around vertically. There we go. And then we take the board, cells, row and column, and we set it to glider, d_row, d_column, like this. So essentially we just copying this pattern, like we're slapping the pattern onto the board. Right. Okay, so now I can actually slap a bunch of them. So how many of them I want to put there? I want to put, oh my god, let's say 5. Plus I. Put glider at, I provide the board FG, and so in terms of Y, I'm gonna keep it on the same level, I suppose. Might as well actually, yeah, I might as well actually do something like this. Multiply by 2, maybe 3. Yeah, it's multiplied by 3. I think it's gonna create a pretty interesting pattern. And I forgot to rebuild. Is it gonna work now? And it kind of did, but I think it was... I think I need 4 instead of 3. I think I need 4 instead of 3. And there we go. So that's pretty cool. I also want to be able to rotate them and whatnot. So let's say that I want to have like 10 of them. Yeah. That's pretty cool. But to rotate them, right, I basically have to transpose them and whatnot, but yeah, maybe for now I'm just gonna keep it like this. So random row, random board, let's not put the random board in here. Right, let's commit whatever we have. Put a bunch of gliders into initial seeds state. Okay, that's pretty cool. And again, I'm gonna declare the seeds done. We explored the seeds a little bit, we implemented it, and it looks pretty cool. All right. I'm gonna push that right into the repo. Again, you can find all the source code in here, so I'm pushing it live, so it should be available for everyone. Now, what we can do? We should implement Brian's brain, but I want to do that after I make a cup of tea. Does anyone have any questions while I'm making a cup of tea? Do one like DVD logo that never hits the corner. I don't know how to do that. Yeah, so the problem with these streams, with Cellular Automata streams, is because it really hurts the encoding, right? Because it's a lot of moving things. It probably hurts the encoding right now. So the tea that I'm drinking right now is Earl Grey. It's definitely Earl Grey. Does anyone have any questions? Maybe? Or everyone is just busy doing their own thing? Is this much harder to do in something like Haskell? Depends on your experience, I suppose. I can't wrap my head around how you do that. Actually, translating imperative code in Haskell is a relatively easy thing to do. Relatively. Right, so essentially in any imperative program, you have an implicit state that you modify all the time, right? So, let me see. Right. So, you have a program, right? And yeah, you have a particular state that is comprised of 2 variables. And throughout your program, what you do, you modify that state by adding new things, then subtracting some things, and so on and so forth. So you basically, here's your state, and here are modifications of those states. Right. So essentially, to program something like that in a functional way, in a purely functional declarative way, instead of having state like that, you would have it as a value, right? So you would define something like data state, which is state something like state x, which is an integer, and so on and so forth. And then you're gonna have a function like f1 that takes a state and returns you a new state, and within that function you take that state, you extract x out of that state, right? Then you add 10 to it, and then you save it back into the original state like this, and there you go. You just encode it as a function, this line of code. Right, so this could be f1. Then you can have f2, which does kind of a similar thing. Right, kind of a similar thing, but instead of modifying x, it modifies y. Right, so in that case, it subtracts 20 from from y, and there we go. You have original state, so your original state is going to be like something like 2030, right? So, and that means your default state is going to be state 2030, and then you take the default state, you apply f1, you apply f2, and essentially you encoded the same thing in a declarative purely functional way as in C here. This is like a very rough and like example, but that's pretty much what it means, right? You basically need to learn how to identify those states that are implicitly there in imperative programs, and you just have to write those states explicitly. That's it. Seriously. It's just that's it. So the actual difference between like imperative code and functional code is that the state is just explicit. So, and that's why I lost interest in Haskell recently, because, yeah, I get it. Is there something else here? So, yeah. Instead of modifying state, you create a new one. Yeah, I guess, essentially. But in case of Haskell, it may not copy the whole state, because you also may have like persistent data structure that actually don't have copies of the structures. Essentially, the next state of the structure is the previous state plus modifications that you need to get the new state. So it usually sometimes like can be stored more efficiently than just copying around. So yeah, that's it. And what's interesting is that you can have different abstractions on top of that. So you can turn this into a state transformers, right? So this particular function is essentially a state transformer, right? So it takes one state and transforms it into another. And what's interesting is that you can actually demonstrate that such function that takes one state and returns another one is a monad. So that means you can compose these state transformers in a very monadic way, and can even have like a do notation that will make your Haskell code, which looks like this, look like that. So I tell that over and over again. So what you do in Haskell, what you do to program in Haskell, you first re-implement C, and then you program in C. And this is not a joke, seriously. So to do anything useful in Haskell, first you need to reinvent imperative language, and only then, once you have imperative language, reinvent it in a functional one, you can do something useful in it. So yeah, that's pretty much the gist of pure functional programming. That's it, seriously. Anyway, so what I wanted to do, I wanted to actually make a cup of tea. I'm not saying that Haskell is bad or a functional approach is bad, and I'm just saying that after you sort of cracked this sort of idea and you build in your head isomorphism between imperative programming and functional programming, it doesn't really sound as exciting anymore, right? Yeah, it's just the same thing, but from a different angle. Yeah. So once you realize that, it's kind of like, yeah, it's just another way of programming the same thing. All right, so let's make a small break. So it's gonna be, I think I'm not gonna make a small break because I'm gonna quickly go to the kitchen, turn on the kettle, and I'm gonna be back. Well, it's actually not the whole truth. I didn't tell you the whole truth about Haskell and imperative programming and stuff like that. There is more to that. There are different techniques that exploit the laziness of Haskell. And basically, one of the technique is to, instead of modify the state like that, right? So basically you have initial state, you have a bunch of functions that transform the state, and you compose this function. There's another approach to the same idea, is to create an infinite data structure that consists of all of the possible states, right? In Haskell, you can have an infinite data structure that is computed as you iterate through that data structure, right? And essentially, you can generate something like an infinite list of states. Each state depends on the previous one, and once you iterate the state, you sort of modify the state and move along. It's kind of like a different, completely different approach to that, and it's even more difficult to understand than this. But to be fair, it's yet another angle. It's just a third angle, right? So the first angle is imperative programming, the second angle is function composition, and the third angle is basically infinite data structures consisting of the trail of the states. But they still pretty much describe the same thing. None of them are more superior than another ones. They're just different angles on the same thing. It's like you know, Turing machine and lambda calculus. Both of them Turing complete, both of them computational models as just different angles at computational models, pretty much. So that chair demonstrates that soldering is one of Twitch's more genuine streams. What are you talking about? I lie all the time. So, okay. So we need to implement the Brian Brain, right? Let's implement Brian Brain. And once I implement Brian Brain, I'm pretty sure I will be able to extract a lot of duplicate code. But I'm not 100% sure about that. So how should we call it? Brian's Brain. Brian's Brain? Oh, yeah, God damn it, I keep misspelling it. So Brian as a name is IA, and AI is brain. Brian's, oh my god, this messes up. This name actually messes with my brain, since I'm not an English speaker, so it's just, I never thought that it's just, you know, swapped two characters. That's very strange, okay. Brian's Brain. There we go. Ban English. I don't know. I could start speaking Russian, but to be fair, my knowledge of Russian grammar is even worse than knowledge of English grammar. So, to be fair, Russian grammar is even more complicated, so I still don't know. It also has shit ton of exceptions and stuff like that, so... Brian's Brain Generator Factory. I see. Add Brian's brain to something. Why? Why would I do something like that? I can speak Japanese. Cool. Is it your native language? Or is it your second language? You should check out the powder toy. I checked it out a long time ago. Powder toy is actually a very old thing, isn't it? Right. I think... Yeah. I think I checked it out when I was second year in university, and I graduated from university 8 years ago. Okay, so in university I was 5 years, I graduated 8 years, so I was second, so 3, yeah, I checked it out 11 years ago, so does it count? So, Or did it change over 11 years? No, it's my second language. English is my native. I can somewhat read Latin. Oh yeah, the reason why I'm asking is that there's a really strange thing. Like, I don't see any Japanese people online for some reason. Right, I stream almost every day and we have people from around the world, right? And I don't see any Japanese people for some reason. And even outside of Twitch. Yeah, they keep to themselves. I also don't see many Chinese people, especially the ones who live in China specifically, and I know the reason, right? So because they're like their internet is closed, but I do see occasionally Chinese people who are outside of China, like for example, who migrated to Europe or to US. So, but as far as I know, there is no technical like limitations for Japanese people to chat in English online. So it must be some sort of a cultural thing. It must be some sort of cultural thing that they just isolate themselves intentionally without the government forcing them or whatever. Do you have a master's degree? No, I don't have a master's degree, fortunately. Or maybe fortunately, I don't know. Are there some French people here? I don't know if there are any French people right now here, but yeah, definitely, we definitely had French people in the audience. They just don't like it. It's actually mostly because they don't speak English. But I mean, it's not really good reason, right? Because they don't speak English because they didn't learn English. So the question is why they didn't learn English, because they didn't feel the need to do so, right? For example, recently we had a lot of like more and more Russian people online, and majority of Russian people who you can see online in speaking English are the new generation that is completely separate from the previous generation who lived in Soviet Union. People who lived in Soviet Union, who were raised in Soviet Union, they're actually culturally closed and they don't want to learn anything new, and they don't want to communicate with outside of the world, right? But the new generation of Russians, they're really open to communicate with the rest of the world, and they usually speak English, and majority of them speak English even better than me, which is kind of interesting. There are Japanese streamers on Twitch, but only in Japanese, never English. Oh, okay, so that actually confirms my theory that they're just culturally closed. Ever try a self-hosted streaming site? No, I never tried that. I speak English because I'm a filthy brat. All right. Cheers, by the way. They learn English in school, yeah, but the problem is that they never actually get proficient in it. Culturally, they're not comfortable doing things they're not good at, which puts them in a negative feedback loop. Oh, that's actually very interesting. Huh. Alright, that makes sense. Alright. So let's read about Brian's brain. As a cellular automaton devised by Brian Silverman, which is very similar to his seeds rule that we implemented just recently. Brian's brain consists of infinite two-dimensional grid of cells, but unlike seeds, each cell may be in one of three states: on, dying, or off. Each cell is considered to have 8 neighbors, the Moore neighborhood. Oh, it even has a name for that. Oh. Okay, I didn't know that this has a name. What is an automaton? You can Google it up. Automaton. Let me Google that for you. A moving mechanical device made in imitation of a human being. But that's not a really good definition, because we are talking about cellular automatons. Automata. Yeah. So. Like, why? Google, why? Just why? Why do you do that? Who at Google came up with that horrible idea of screwing up with my URLs? Who came up with it? I want to see that person. And I want to personally tell them, looking at in their eyes, you're fired. I know that it doesn't change anything and you're probably not going to be fired, but I want to just tell them right in their eyes. I'm sorry. This just makes me mad. Like, why? Just why? Who did this? Mod? Ban? Permaban. Okay, so this is this. This is the thing. AMP, I don't even know what is AMP, to be fair, but yeah, I really don't like this idea. What am I doing? Okay, so yeah, I didn't even know that this kind of thing has its own name, right? So essentially, I can now say use Moore's neighborhood, and that implies 8 neighbors. Okay, that's pretty cool. Oh. Okay, so as in seeds and command game, in each time step, a cell turns on if it was off but had exactly 2 neighbors that were on, just like the birth rule for seeds. All seeds that were on go into dying state, which is not counted as on cell in the 8 neighborhood, and prevent any cell from being born there. Cells that were on the dying state. Okay, so it's literally the seeds, but the cells die longer. Oh no, more obscure shit for next year advent of code. Excuse me? Did I miss anything? Oh, you mean... Ah, I see what you mean. You're referring to me saying that now I can just say Moore's neighborhood and without explaining shit, yeah. Do these always have the same pattern? I mean, which ones? No. Please read more about cellular automatons. Okay, so it's literally the same thing, it's just the rules are kind of different. So what I'm thinking, how can we abstract all of that stuff away? Is there any way for us to abstract it away? So we can have a single definition of the board across all of these examples, right? So, do the cellular automata have like Brian's brain, seed, game of life? Do they have like a name of a class? They do belong to the same class, same family. So like cellular automaton. A cellular automaton say is like in the sense of being similar to Conway's game of life. If it meets the following criteria: the array of cells of automata shares 2 dimensions, each cell of automata shares 2 states. Convention. So that means the Brian's brain is not really like. So what if it has more states? Like and subscribe. Oh, I'm sorry. Notation for rules. Brian's brain. But Brian's brain, that actually doesn't meet that criteria, right? Because it has 3 states. In each time step of the automation, the new state of the cell can be expressed as a function of 2. It's common to refer to it. Many different terms are used to describe this class. It is common to refer to a life family. Okay, so I'm gonna call them life family because it makes more sense in my opinion. So essentially, I wanna take the common code between game of life and seeds and extract it to a header called like life. Like. I can use you to do what? Oh, subscribe. Thank you so much for 2 months of tier 1 subscription. Thank you. And welcome to our subscribe. Oh my god. I'm sorry if I'm saying something stupid because my brain switches context way too fast, right? So I already forgot that I was talking about that I made a joke like subscribe. I was thinking about like next thing that I'm gonna do. And I completely threw away this context, so I'm really sorry. But thank you so much for 2 months of tier 1 subscription. All right. So what I want to do, I want to actually extract all of that into like reusable code. Superina, Oh my god, thank you so much for Twitch Prime subscription, your first subscription by the way, and welcome to our epic Automata Club. Alright, so let me see. So, and obviously rule 110 does not belong to that family, so it's not gonna reuse this kind of thing. Okay. So what I'm thinking now is we're probably gonna have this board definition, but we're not gonna have a cell definition because different cells may have different states and whatnot. Yeah, and we also can have different ways of computing neighbors, and yeah. All right, let's do live.h. So it's gonna be if and def live.h, define live.h, and it's gonna be end if live.h. So here we keep the common code for all of the cellular automata from the game of life family. So I also want to actually split this thing like that, and maybe give a link to this article, right? To this article, but I'm not even sure if link to this article is a good idea, but I just want to, you know, mention why we have this header at all. All right, and we're gonna have just a board definition. It's gonna be just a board, and the thing about this board is that we have a cells, and the amount of cells depends on rows and columns. Okay. And one of the things we need to have here is an ability to calculate neighbors, right? As you can see, I don't have a type for this cell because you may have different kinds of cells here. Board neighbors. So where is the seed? Where is the seed? Neighbors. Okay, I'm gonna put this thing here, and essentially we're gonna abstract that thing slightly away. We're gonna also provide the value of the cell, which cell we are trying to count. So, and we're checking if cells equal to cell, you see? And there we go, we abstracted that away, and now this function is actually reusable among all of the lifelike automata. I don't know how to say that, sorry. So next board is very interesting. I think next board should be more abstract. It should probably accept the rule, right? It should probably accept the function that applies the rule. But the question is how we're gonna even do that. So, all right, so let me grab this thing. So next board takes the previous one and the next one, and then it should take something like a rule. And what this entire thing will accept, right? It will accept a row. Definitely the current row and the current column, and it probably should accept previous and the next board as well, so it can compute neighbors and whatnot. So maybe I'm gonna put it like that. So it's gonna be pretty big function, and essentially how we're gonna apply it? We're gonna apply it the following way. We're gonna call rule previous next row column, and then we're gonna just apply it like this, boom, and we're gonna collapse this entire thing. So you will have to implement that yourself, right? You implement the function rule, you put it there, and it automatically calculates all of that for you. So we don't really have a cell as a type, but maybe we can at least introduce type def for the cell like this. I'm not sure how good of an idea that is, but I think it's a gonna be a good idea because at least it documents what we are expecting here. Yeah, at least it doesn't really add any type safety, but at least it documents things. Right, and then here we might as well put it like that. Alright, so this is the next board, this is the neighbors. You can easily reuse all of that for your stuff. Do we need to have anything else? So yeah, render board, it's pretty straightforward. Do we need anything else? Random, we can try to implement something like random board, but for the random board you will have to provide the amount of cells you have. Right, so yeah, this is a random board, you iterate through all of that, and you can have something like how is it called? Cell count. Cell states, maybe. Cell states. Cell states, you'll have to provide something like this. And yeah, here it is. I think this is the whole thing that we want to abstract away. I don't think we have anything else in here. And obviously this header depends on everything we have in Automata, right? It depends at least at rows and columns. And I think I can quickly now abstract things away. Alright, so I'm gonna just recompile everything. I don't really want to do it like that. Right, let's start with the game of life. Let's start with the game of life, and we're probably gonna introduce things like dead and alive. Right, we don't need cell in here, and we definitely don't need the board definition anymore. We definitely need a render board, but random board is not needed anymore. Neighbors also not needed anymore, and we definitely don't need the next board. But what we need is goal rule, which accepts previous and the next board. Actually, it should accept previous and the next board by const, because it's not gonna modify it. It's not gonna modify it. So it's gonna be just const. And also we accept a row and column, right? So, and we can extract this entire thing like this. To be fair, wait a second, you don't need next. You definitely don't need next, so we can just actually never provide it. Yeah, so rule, you take previous and row and column, and you don't even have to do that. Like it's simpler than that. Okay, so then we count the neighbors for the previous one, then we check everything, and here we essentially just return things like that. Here we return it like that. We might as well actually get rid of the breaks, because return automatically acts like a break, so you don't need that. And you don't need a next board. Put glider at is definitely needed in here. Okay, so that simplified implementation of this thing dramatically, because the only thing we had to implement is render board, the rule, and also how to put a glider and whatnot, right? So we only needed to do that. Hello, lazy grid? I'm not sure what you're talking about. Alright. So let's try to recompile this entire thing. And it's gonna fail, obviously. Field omitted. Oh yeah, because I actually forgot to make it 1. Alright. So, unknown board. Let's include live.h. Let's include live.h. Do we have anything else here? Okay, so, and now I don't even... so in the next board, yeah, I don't have to provide the next, because it's my job to handle the next. Too few arguments. Oh, you have to provide which one you're counting. We're counting alive cells. And return with value function, return void. So that means I have to return cell in here. And now, when I calculate the next board, I have to provide the goal rule. Yes, I'm just providing the goal rule. Man, that's it. That's actually pretty cool. You know what I'm thinking about? Since all of this Game of Life's game will have pretty much the same loop, might as well all subtract it away. Because the only thing they need is essentially a function to initialize your board, the rule, and to render your board. You know what? Why not? Why not? Yeah. So we can abstract that shit away as well. Huh. And oh shit, that's gonna be cool. Okay. Two. So essentially it's going to be the following function, right? So something like life event loop, and it will accept, I guess, three main functions. It will accept init board, right, which doesn't do anything. It's just going to be init board, which accepts your board, right? So it does that. The next thing it accepts the rule. So, and the rule is basically already defined here. So this is the rule that's going to be used. And it also will accept a render board. So it's going to be something like a render board, which accepts constant board. And I guess that's it. Yeah, it doesn't accept anything else. So you only need to implement this kind of stuff. There we go. And we might as well also, yeah, have an integer here, which we can use then later. So the idea is the following. So I don't have init board. Let me introduce it. So it's going to be init board. Right, and in there, I'm going to actually put this thing. Right, so here's that. And I can just quickly replace this entire thing like this. Here's how we initialize everything. Then I take this entire stuff, why Emacs over Vim? This is Vim. I don't know what you're talking about. Look, in the title it says Vim. So it's a really strange question. I don't understand your question. Sorry. It's Vim. It's literally Vim. Alright, so next thing we're gonna do is gonna be init. How do you zoom? I'm using a special application, this one. Board, and we do board fg like this. So we initialize everything here, and I don't have to do this thing here. Then we calculate the next board, but we use the rule that is supplied by the user, right? And then we render the board. Yeah, we use render the board. And that's pretty much it. And essentially, I can replace this entire stuff with just a function, life event loop, init board, then goal rule, then render board, and that's it. So, and I can move this entire stuff. Right, I can move this entire... I'm not sure what would be the best way to actually do that. I might as well move it here. So we're gonna have like a bunch of these things in here. And can I move it to life now? Yeah, that's pretty good. So now the entire Game of Life implementation consists of just how you render the board, then the Game of Life rule, and then initialization and whatnot. And with initialization, we actually do everything here. And this is the main event loop. And this can be reused across all of the life-like cellular automata. So I think that's pretty cool. So let's see if it compiles. Probably not, but we can always fix that. It compiled first try. What the fuck? Got cooler, by the way. So yeah, seems to be working. Still working. Cool. Now, so let's do a committee. introduce framework for lifelike cellular automata. I hope I actually spelled it correctly. I think I did. So I'm going to push that right into the repo. And I'm going to rewrite seeds in terms that think as well. So what we have to do now, we just need to include live.h in here, and instead of having this thing, we can define it like that. It's going to be define, and we're going to just remove it like that. And there we go. We have off and on. We don't need this definition. We don't need this function. We don't need this function. Well, we still do need it because we need to have a rule here. Let's actually create a rule. So it's going to be cell, let's call it seeds rule. It accepts the previous state of the board and row and column. And first thing it does, essentially, it computes the neighbors. It computes the neighbors, and then in this particular case, we return on or off. There we go, that's the whole thing, but we still don't need next board. We do need a render board. We don't need a random board, that's for sure, because I'm pretty sure I extracted that. Yeah, I do have it here, so I don't need that. I definitely don't need that. Seeds event call. Okay, this one is interesting. Seeds event callback. The thing about that stuff is, yeah, we can probably make it available on. This one is complicated because we need to know. We need to know how many of the cells you can have. But maybe we can remove that for now. So put glider at, it's one of the, okay, so put glider at could be actually abstracted away. I think it could be abstracted away. Basically put a figure at, but apart from that, we can do something like this. Init board. And I'm gonna actually copy paste this thing here, and we're just using the board in here, right? And I think that is it. So essentially I can now do the following thing: live event loop. So first we init the board, then we render the board. Actually, seeds rule. And the last one was the render the board, and there you go. So that organized the event loop for you. But we still need to do something with this specific thing, and I'm not 100% sure what. Okay, make -b. Okay, and did it compile because we don't have board neighbors. Oh yeah, board neighbors accepts what these cells we're counting. We're counting on cells. Right, we're counting on cells. Cool. And I still need to integrate that into the whole framework, but the problem is that it needs to know how many of the cells we have. So we need to pass that information to the framework somehow. Well, we can probably pass it here, right? So we have init board, seed rule, and render board, and I can then say I have two states of the board, right? I have two states of the board. So I don't know. That could be the thing. Or maybe we're gonna just assume that you can only draw between 0 and 2, which is kind of a strange assumption, but okay. Maybe it's gonna be okay for now. Live event loop, seeds, event callback. Hello, Landward Scammer. I hope I pronounced your nickname correctly. Welcome. Live event callback. So here is an interesting thing. To do live event callback assumes that there is only two there's only two kinds of cells, 0 and 1. Which is probably pretty good convention, I think. This is basically the convention that you have to follow if you wanna use this framework for the live thingy, right? It's a reasonable convention in my opinion. Anything else? Okay, so what we have here. Okay. So that means we have to make this board available globally. Yeah, we need to make it globally available. Which is, I mean, that's what we do anyway. Yep, so if I try to run seeds, this seems to be working, and I can also modify all of that. And I can also put a bunch of oscillators, and when they hit the oscillators, they will become a chaos. It will turn into a chaos. Okay, that makes sense. So I didn't really break things too much. And what's interesting, the side effect of all of that is that now you can also edit game of life, which you couldn't do before, right? Because we're using the same framework. Right, so, and I can stop and I can draw some things in here for the game of life, and that will work automatically, and we're using the same framework. It's kind of interesting how we have several layers of framework. So first we have Automata framework, which just gives you a basic event loop and basic drawing functionality. On top of that, we build another framework, which is a live framework, which gives you ability to write life-like cellular automata. So you see what I did here? So here are two frameworks. First one, Automata, and the life. So that's pretty cool. How do I exit? You press Q. You have to press Q. Did it work for you? Did I not document that? This one is on you. There's literally a huge controls table that documents everything. You didn't read it, this one is on you. I don't even feel bad about you. You deserve that. You literally deserve that. All right. So, I was like, I thought for a second that I forgot to document that. No, I documented that. Okay, everything's okay. Alrighty. And though you managed to build it, wait a second, you actually downloaded NIM compiler, right? And you build it yourself? That's actually pretty cool. So it actually puts away a lot of people when they see this program. They want to use this program, but the fact that you have to build it yourself. Oh, you're using Arch, I see. So, I mean, it's probably easy in Arch. And also, yeah, you can only use it on Linux, unfortunately. It literally doesn't work on Linux because it uses very specific Linux functionality, which is not available on Windows. But on Windows, you have a lot of other similar things that are probably better. All right, so so now we have that. Okay. Rewrite seeds using the live framework. I'm not sure if I'm doing a good job. Windows has a built-in magnifier thing. Okay. So, but is it as good as Boomer that can do things like that? And wow. Probably. I don't know. I haven't used Windows for quite some time already. Maybe it's better. Okay, so we're gonna have a Brian's brain. Does it already? It doesn't really build automatically. Brian's brain. Okay, let's try to build that. Doesn't have the flashlight feature. Too bad. Too bad. So yeah, there we go. We have Brian's brain. So the thing we need to do now, we need to include automata and life. So essentially, I'm going to define the following states of the cells. Off is going to be 0, on is going to be 1, and dying is going to be 2. Right. So, and the reason why I'm defining them like that is because the convention is 0 is dead, 1 is on, right? And all of the controls are built between, like, around these conventions. That's why I have to do it like that. But it does have TTS. Does Boomer have TTS? No, it doesn't. It doesn't have it, unfortunately. All right, so let me see. Oh, by the way, I need to be able to actually ignore all of these things. Yeah. So essentially, if init board is not available, so that one. Okay. Sure. Live event callback. So rule. Render board. If render board. Next board. Okay, this one is interesting actually. If there's no rule, we should probably do nothing. If rule. Yeah. So essentially the reason why I'm doing all of that is that because I want to use this function and provide nulls for all of them, and I want this stuff work. Hello, Drucker. Look, imagine activities of there that don't work on Windows. Imagine using Windows. Got it. Got it. Alright, so what do we get? So this one is going to be null for now. I'm using Debian stable. I'm curious which branch works better on desktop PC. I have no idea. So here's my approach. Right, I'm just using Debian stable. So, and every time I need a fresh software, I literally build it myself from scratch, outside of the package manager. And I just install it at /user/local. I think yeah. So basically, I install it there. So yeah. So I used a lot of different distros, and I've kind of got tired of, you know, different pros and cons of the distros. So I just settled on one distro that just gives me an environment, some sort of environment, and I just adapt this environment to my needs myself without relying too much on repos and stuff like that. So if the software that I need is available in repos, cool, I'm gonna use it. But quite often, in case of a Debian stable, it doesn't, so I just build it myself. It's just easy. I pretty much use Debian like Slackware. Yeah. And I don't really care about specific distro. I just need a kernel, Linux kernel and shell, and then I can just build everything myself. Alrighty, so we're not gonna initialize. We need to come up with the rule. Okay, so I'm gonna call this thing BB. So it's gonna stay for Brian's brain. You Arch, by the way. Thank you for telling us that you're using Arch. I really appreciate it. Classic. Am I right? Alright. I have found Debian to be quite nice in terms of the software provided in the core. Yeah, probably. So, oh, by the way, rule is supposed to return a cell. Yeah, I think I did a fucky-walkie in here. So, what's the rules of the Brian's brain? Brian's brain. Where is my Brian's brain? Here it is. Here's the Brian's brain. So all the cells that were on go into dying. All right, so I probably need to compute the neighbors first. Const int and bors is going to be board neighbors, previous row column, and I'm counting actually on. Right, if this cell row column equal to off, right? If it's equal to off, it becomes on if it has exactly two neighbors, right? All cells that were on, two neighbors become on. Okay, so return neighbors equal to, it becomes on, otherwise it stays off. Right, if this thing, I might as well actually do a switch here. I think switch would work a little bit better for this particular case. I think switch is actually good. So case off, nice. Case on, always return dying. Case dying, always return off. Yep, there we go. So that's pretty much the rules of Brian's brain. Pretty much the rules. And yeah, we're gonna put a BB rule in here. So, and another thing we need to implement a render board. Render board. So it's gonna take a board, and we just need to render it. I really didn't read my message. Baby rule, yeah. Alrighty, so okay, so it's gonna be row 0 row less than rows plus row. I might as well actually do something like this. Column less than columns plus column. And the way we're gonna do all of that, okay, so we need a mapping between different states of the cell, right? So it's going to be uint32 cell caller, and we're going to have 3 of them. So off is going to be background. Yes, yeah, but PTTV is like okay. On is going to be foreground. This one is on Twitch. My internet was absolutely fine. It didn't even reconnect. I just saw like insane amount of Fs instantly. And no reconnection has happened. So this one is literally on Twitch. Oh, thank you, Adnan. Thank you. Alright. Yeah, this one is on Twitch. I don't know what's going on. They probably broke something recently. Alrighty. So does it compile? Okay, so the control reaches, and well, we can put some sort of assert here. I might as well actually put it into the default one. right? So it's going to be assert false BB rule unreachable, something like that, and assumes. Well, it's not a bad name for this thing either. Okay, so we don't have assert. I need to include that here. Might as well actually just build. I don't like how huge this name is. I'm gonna call it BB. Emacs. Brian's brain. So this is BB. Okay. I should probably only build B. Okay, so here's BB, and I'm gonna pause it, and I cannot set anything in here. Okay, it didn't work at all. Oh, this is because I didn't set the render board. Okay, render board. So let's actually set the render board. We go to pause, and it still doesn't, because I didn't rebuild, of course. Sure. So now we can set these things, and let's see what's gonna happen. So essentially, the pink ones are alive, and the blue ones are dying. So, and we can only add the pink ones. But that creates a pretty interesting pattern, which also dies out. And it creates a lot of that's actually super cool. Holy shit, wait a second. If you make them in diagonal, that is so cool. Let me show you. I'm not sure how visible it is. But essentially, rows. Let's make them 10 by 10. Right, we're gonna make them 10 by 10, and I'm gonna slow down the whole thing, and we're gonna see what's gonna happen. Right, so, okay. So, if I make them like this, this is so cool. So if we make it, so if you make it super fast, actually. Yeah. What if I make it like that? It's cool how it just fades away or something. But how can I make like a stable pattern? That is so cool. Alright, so maybe we can use a random board. So this is a pretty interesting rule, I would say. What are Cellular Automata rules? We are currently exploring Brian's brain. So this is what we're currently exploring. I cannot even type, unfortunately. Can somebody please issue the project command where we have links to all of these Cellular Automata? Thank you so much. Thank you. So you can find all of the links there, right? You can find all of the links there. Cool. So what I need to do here, I need to be able to initialize this entire thing. So we do have a random board. I wish C had partial application. I wish C had partial application, but unfortunately it just doesn't really work that way. Okay, so cell state and it's not automaton, it's automata, yes. Init board, and we're gonna just put it like that. And I'm gonna first, yeah, so you see what I have to do here? look, I'm passing init board as a function that calls another function and defines one value. Why? I wanted to do a partial application. Where is my bake? How do you do bake in Jai? I don't remember. So I think it's something like init board. I think you can even do it like that. So bake random board, right? And you can probably, I don't remember if this is how we do that, but so yeah, it will generate like a new function or something. Fortunately, this is not Jai. Bake, it's a partial application in Jai, but I don't remember how to use it, unfortunately. Oh shit. Holy fuck, this is so cool. The fact, like, two colors make it so cool. Oh shit. That is way better than Seeds. Seeds just very chaotic. It is very chaotic. This one, like, it has structures. Holy fuck. This is so cool. Oh my god. I love it. It actually creates very beautiful structures and shit. Oh fuck. I wonder if it's gonna die out at some point. It's probably gonna die out. Oh no. And it actually creates more interesting stuff than Game of Life. Nice. I like how Kevin gets when he makes something shiny. Yeah, I guess. I'm a huge child. It's really cool, so thanks for making it for us. You're welcome. That's so cool. You can pause it at any point. I wish I could explore more, but I feel a little bit tired. So, yeah. I think it's time for me to go, boys and girls. I've been streaming like for 5 hours several days already, and it's kind of difficult for me to maintain this pace. Look at that! Look at that shit! Look at that diamond! Holy fuck. So, yeah, I guess I'm gonna finish the stream here. I'm really sorry that I didn't manage to find any time to explore the gas thingy or other things. Maybe we're gonna explore them more in the future. I don't know, we can make another you know, Cellular Automata stream tomorrow. Why not? Sounds like a pretty cool idea. Since we have like a whole list of these things, we might as well just go through them. So yeah, let's actually make another one of the streams tomorrow. All right. So tomorrow we're gonna continue like developing more of these automatons. Yeah, that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one. See you tomorrow. We're gonna continue doing this thing. I made the decision. Check out our schedule, which is completely irrelevant because I stopped following it. Check out the source code of this thing. By the way, check out the source code of this thing. So it's God damn it. Okay, so I don't have a ability to send messages. Let me restart my chat arena. Just a second. So yeah. You can find the source code in here. Schedule. It's dying. It's dying. Oh no. Check out the VODs channel. We upload the VODs there. And check out our Discord server for offline discussion with the community. Yeah, I'm gonna commit it. Let me actually commit it right now, so I don't forget to do that. So I'm gonna git ignore bb, and it's also gonna be readme. So like this, and implement Brian's brain, and I'm gonna push that right into the repo. So should be available now. And yeah, that's it for today. That's it for today, boys and girls. And I see you all tomorrow. Love you.